Okay, I want to bring a slightly different perspective that is provided by this book called Designing Climate Solutions by Hal Harvey and co-authors. Obviously, the subtitle there is A Policy Guide for Low Carbon Energy, which gives it a slightly different focus than the book we looked at in terms of drawdown that is included some policy aspects, some social aspects, and then different sectors. So these things map onto that space as well, but from a slightly different point of view, or slightly different implementation, let's say. So here you start by looking at what we already looked at, annual emissions out to 2100, where business as usual would take us, and where Paris pledges are going to take us. Substantial reduction, but very far from the 2 C pathway with 50 or 66% probability. And if we are here in 2020, obviously we have to go way down close to net zero by 2100, and there are lots of issues about this net zero goal. There are people now saying that's not the best way to go about it as well. I go about it either. Okay, but nonetheless, extended Paris pledges are expected now from the signatories, because Paris pledges are not going to get us where we want to go. So this is probably going to put us more than obviously 2 C plus. There are lots of issues even where Paris pledges are headed in terms of actual action and implementation and so on. So this is how this book looks at it. Looks at the total emission, which I think I chopped off, so let me stop and come back. So sorry about that. So the figure, I had chopped up something, as usual, not being as careful as I should be. So business as usual cumulative emissions between 2020 and 2050 are estimated at 2,253 gigatons of CO2 equivalent. This depends, again, as before, projections always depend on a lot of assumptions about everything from population, technology, policies, energy sources, carbon intensity of emissions, land use, transportation, and so on. Nonetheless, keeping that in mind, to get to 2 C target, we need, with a 50% probability, 50% chance of hitting it, we need to be reducing the emissions down to here 1,185 gigatons. So that's how much below business as usual we need to get. So then this book arranges things in this way, which is slightly different than what we did before, but you can see that we essentially come back to the same issues, but a different type of mapping. So here we are with the business as usual, and here we are policy-based emissions reductions wanting to accomplish 1185 gigatons by 2050. So policies in just 5 sectors plus land use sector reductions could be enough to have a 50% chance of hitting 2 C. So this focuses this much more without going into the details of what's in each sector, of course. So industry 27%, electricity 21%, land use, transportation, buildings, and cross-sector policies like carbon pricing, which we will look at a little bit. And the goal here is to then again focus on the countries that are right now the largest emitters. So you have China, US, India, Indonesia, Russia, Brazil, and Japan, with the rest of the 8 countries emitting between 0.5 and 1 gigaton, whereas these are more than 1 gigaton. There are lots of details per capita and also embedded carbon. For example, China's emission is high, but all these other countries are importing things produced in China. So where do you count the carbon? At the source or where it's consumed? So there are lots of details, of course. 5 countries emitted nearly 0.5 gigatons each. So then the goal is to focus on the largest emitters and then look at sectors. So, and we have seen this in different ways. This is for 2014 emissions in gigaton CO2 equivalent. So there is electricity, industry, transportation, buildings, and others. So we looked at each of these under drawdown in a different way. So business as usual, again, compared to policy-based emissions reductions, how are the different policies going to affect the reductions in each of those sectors? So industrial efficiency standards, industrial process emissions policies, complementary power sector policies, and renewable portfolio standards. So here how you would get close to 27. This remains there. So building codes and appliance standards, fuel economy standards, urban mobility, fee-bait, so that's kind of incentivizing vehicle electrification and land use. So you can see how policies can be designed by mapping into this kind of phase space as opposed to what we did for each individual sectors like energy, buildings, food, materials, and so on. The book then goes into providing some energy policy design principles. I won't go into the details. You should definitely read the book if you're a policy wonk or trying to be doing research in policy or working in policy. Performance standards. So this is for energy policy. Create long-term certainty of the standards to provide businesses with a fair planning horizon, build in continuous improvement, focus standards on outcomes, not technologies, prevent gaming via simplicity and avoiding loopholes. So those are the kind of performance standards. And then you need economic signals like create a long-term goal and provide business certainty, price in the full value of all negative externalities for each technology so that unintended impacts on the pricing, etc., can be managed, use a price finding mechanism. So you can see that this is all more market-based policies, so it's going to drive towards less regulation, more market forces, and then asks for supporting R&D, like creating long-term commitments for research success, using peer review to help set research priorities. So there is government role here in terms of setting and supporting R&D agendas for energy in this case, but the same works for other sectors as well. Here is another way it is presented: most effective policies for reducing emissions in each sector. So power sector, transportation, building, industry, and cross-sector. So renewable portfolio standards and feed-in tariffs, complementary power sector policies, and we have seen many choices like electrical vehicles in our drawdown, but here it's about electrical vehicle policies, urban mobility policies, building codes and appliance standards, industrial energy efficiency, industrial process emissions policies, and then in cross sectors, across all sectors, we have carbon pricing and R&D policies. The feedbacks between policy types drive and reinforcing each other is also looked at here. So economic signals, support for research and development, and performance standards. So the three legs of this stool, let's say. Economic signals can encourage support for research and development, which can in turn reduce the costs of economic signals, and so on. So reduce price shock, accelerate uptake of performance standards, and economic signals can drive performance standards. Research and development can reduce the cost of performance standards, and performance standards can create markets for research and development. So you can see that there is this kind of holistic interaction needed. Just to touch on carbon pricing, this is a complicated issue. I have a more detailed analysis of this in Bending the Curve, the other course I have on my YouTube channel. And here again, putting it in this phase of how much gigaton CO2 equivalent is expected and what carbon pricing is expected to do. Basically, this goes after the so-called social cost of carbon for each additional ton on top of what we have already accumulated. How much each ton of carbon does damage to the socioeconomics and other factors that affect the GDPs and so on and so forth. And again, in that there are two ways. One is market-based, which is called carbon pricing. The other one is more like cap and trade, where government issues permits and then high emitters can buy permits from low emitters who are below their below their targets, so that they can use that saving they make in their carbon emission and sell it to others. So implementations are an issue. For example, Europe gave out too many permits in the 2008 to 2015 time period, I think, and then basically carbon price collapsed. So carbon price has to be held relatively high for people to be able to pay attention and reduce their emissions or pay the penalty. So then they put a floor pricing in California and in Europe, and that improved the situation, of course. There are other social issues. For example, fossil fuels right now are heavily subsidized across the board. So you can see the various amounts of subsidies, fossil fuel pre-tax subsidies per capita measured in current US dollars in 2015. And of course, Middle East countries have high subsidies, but rich countries and even not so rich countries have various levels of fuel subsidies. So where do you put the carbon tax if we cannot even tax the fossil fuel consumption appropriately? So there are socio-economic issues and implementation issues as well, but mostly it's going after corporations, which can include oil producers, and then pass the cost down to the consumers. Then naturally the subsidy will go down. Nonetheless, it's argued that this market-based approach of carbon taxing is technologically neutral, so it doesn't matter what changes in technology come along, each ton of carbon will cost the same. It's a source of low-cost reductions. It creates an incentive that radiates across all sectors of the economy, so it's considered a good tool to implement across sectors and countries and so on. It reduces the information burden on regulators, because if you want to set different standards for cars, refrigerators, air conditioners, travel and so on, then you have to have enormous number of regulations and data. So this becomes very cumbersome, whereas carbon tax is just carbon tax. Any amount of travel you do, food you consume, energy you use is going to cost you by the ton of carbon you're going to emit, right? The price signal affects investment decisions and behavior for existing energy infrastructure for both consumers and the business. So everybody has an incentive. It generates revenues which can be used to reduce inefficient taxes, thus stimulating the economy, ideally. Support a faster, more efficient, clean energy transition through deployment incentives. Accomplish equity goals such as ensuring that disadvantaged communities share in the gains through emission reduction projects in the most polluted neighborhoods or targeted economic support. So there are implicit choices made, for example, of putting dirty power plants in poor neighborhoods, so they can be paid for the price they paid by having a wastewater treatment plant in their neighborhood or a dirty energy plant in their neighborhood, in terms of the revenues from carbon pricing. So there are some ways this tool can be used to help ease out the disparities of the choices that communities tend to make implicitly and explicitly. Okay, so it's a good book focused on policies, and I just kind of gave you a brief run through what the book is all about and how it is approaching the same problems that we talked about in Drawdown, but focusing on policy designs and socioeconomics of the various approaches.